Welcome to the physics session. BSc Physics, third semester, paper name Geometrical and Physical Optics, Electricity 1 and Basic Electronics. In this paper, Unit 3rd, Theory of Dielectrics and Moving Coil Galvanometer. First session, we learned about Introduction to the Dielectric Materials, Polar and Nonpolar Molecules with examples. In this session, first we learned about some of the basic terms, that is conductors, semiconductor, insulators, dielectrics. So first we seen about conductors. Conductors have the high conductivity. Conductors have a large number of free electrons, allowing for easy flow of electric current. Examples of the conductors are metals like copper, silver, gold are good conductors. In this application of the conductors are used in wiring electrical circuit and anything that requires efficient electricity transmission. Now we see the semiconductor. Semiconductor is a moderate conductivity. Their conductivity can be controlled by adding impurities by varying temperature. So examples is silicon, germanium, gallium arsenide are the common semiconductors. Its application is transistor, diodes, integrated circuits, forming the basis of modern electronics. Now we see the insulators. Insulators have the low conductivity because they have very few free electrons, hindering the flow of electricity. So examples is rubber, glass, plastic, ceramics are the good insulators. So application of these insulators are used to prevent electric shock, insulating wires, protect the circuit from the short circuit. So now we see the dielectrics. Dielectrics is a specialized insulators. Dielectrics are the type of insulators that can store the electrical energy when an electric field is applied. Examples are mica, Teflon, certain types of ceramics can be accessed in dielectric. So what is the application of dielectric is used in the capacitors when they stores the electrical energy by separating the charged particles, by separating the charged plates. Now we see the introduction to the dielectrics. Faraday's contribution is more for dielectrics concept. So first he is the first measure the properties of the insulating materials like capacitors. They found that the capacitance will be depends on the materials between the plates. So now in the difference between dielectric and insulating materials are depends on its application. Insulating materials are used to resist the flow of current through it. On other hand, dielectric materials are used to store the electrical energy. Now we see the definition of the dielectrics. So dielectrics is a material which all the electrons are tightly bonded to the nuclei of the atoms, thus are no free electrons carrying current. Hence electrical conductivity of the dielectrics is very low. However, when an external electric field is applied, induced charges appears on the surface of the dielectric. Hence, we define dielectrics as an insulating materials which transmit the electric effects without conducting. So examples of the dielectrics are glass, rubber, oil, ebonite, mica. So daily life we have seen all the effects, all these things, glass, rubber sheets, ebonite sheets, mica, etc. These are all the examples of dielectric. Now the difference between the dielectrics and insulators, certain properties or characteristics, that is dielectrics have used for the purpose of the storing electrical energy in an electric field. Insulators are used to prevent the flow of electric current. In case of polarization, dielectrics are easily polarized under the electric field. Insulators, they may polarize but not effectively. It has less polarization, very low compared to dielectrics. In case of permittivity of the dielectrics is in high dielectric constant, insulators have a generally lower dielectric constant. So now we see the what is dielectric constant. So dielectric constant, it is a dielectric material is introduced between the plates of the capacitor, its capacitance will be increases. The ratio of the capacitance of the given capacitor with a dielectric material filling the entire space between the plates to the capacitance of the same capacitor in vacuum is called dielectric constant or relative permittivity of the material. Thus, if C is the capacity of the capacitance with a dielectric material and C naught is the capacitance in a vacuum, then dielectric constant is defined by K is equals to C dividing by C naught or epsilon dividing by epsilon naught. So, dielectric constant, it is also represented by an epsilon r that gives the ratio of absolute permittivity of the medium to the permittivity in a free space. So now we see the certain dielectric materials with a dielectric constant values, that is in vacuum has a dielectric constant 1, air has a 1.006, propylene has a 2.2, propylene sulfide has a 3. Next mica, you are familiar with that one, 6.8, aluminum oxide has a 28.5, titanium oxide has a 27.7, barium titanate has a high dielectric constant, that is the range from 3000 to 6000. Now we see there are two types in the dielectrics. They are non-polar dielectrics are made up of non-polar molecules and polar dielectrics are made up of polar molecules. Now we see what is meant by non-polar dielectrics. Non-polar dielectrics are made up of non-polar molecules. Their non-polar molecules means is one in which center of gravity of the positive charges like protons coincides with the center of gravity of the negative charges like an electrons. That is, non-polar molecules have a symmetric structure and zero dipole moment. So in this case, number of positive charges and number of negative charges both are equal, hence they coincides with the dipole moment is zero. So examples are hydrogen, nitrogen, oxygen, carbon dioxide, etc. So dipole moment of these gases are 0. Mu is the dipole moment, total dipole moment is 0. So now we see the polar molecules. So what is meant by polar molecules? Polar molecules is one in which center of gravity of the positive charges is separated by the center of gravity of the negative charges. It forms a finite distance. The polar molecules thus electric dipole moment and has an intrinsic permanent dipole moment. It shows an dipole moment even in the absence of electric field. That's why it's called as an intrinsic dipole moment. Examples as water molecule, hydrogen chloride, carbon monoxide, nitrogen oxide, NH3, etc. Now we see the differences between polar and the non-polar molecules. Already we are seen about the examples. Polars are the hydrogen chloride, H2O, NH3, etc. Non-polar is N2, CO2, carbon tetrachloride, etc. So the characteristics, certain nature between the polar and non-polar dielectrics are: in this nature of molecules, in case of polar dielectrics have a permanent electric dipole moment. In case of non-polar molecules, it has no permanent dipole moment. Means in the absence of electric field, it has some dipole moment. In this case, zero dipole moment. In case of dipole moment, in case of polar dielectrics, that is presence without external electric field. In the absence of external electric field, polar dielectric shows an certain dipole moment. That's why it has an intrinsic permanent dipole moment. In case of nonpolar dielectrics, it's only induced only when external electric field is applied. It shows a small dipole moment after the application of electric field. So, next one, alignment of the field. In this case, application of the electric field direction, dipoles are aligned in polar molecules. So, in this case, applying the, in case example, electric field applied in forward direction, dipoles are aligned in the direction of the electric field. In this case, no alignment of the alignment until the polarized by the field, means until the polarization takes place they didn't shows the dipoles are arranged in the direction of the electric field in case of nonpolar dielectrics. Next, polarization mechanism. In this case, polar dielectrics obtains an orientational polarization due to the real dipoles. In case of nonpolar dielectrics, electronic or the atomic polarization, it can be obtained by the application of electric field. That's why it's called as an induced dipoles. In case of dielectric constant of the polar dielectrics is generally high. In case of nonpolar dielectrics, it has a lower dielectric constant. Next we seen about electric dipole. So electric dipole, it is the two equal and opposite charges separated by a certain distance x. It is called as an electric dipole. Means two charges, that is plus q and the minus q, they are separated by a distance x, called as an electric dipole. So electric dipole moment. Electric dipole moment, it is a measure the separation of the positive and negative charges with a system. It means how much of the distance will be separated by these two dipoles. It is known as an electric dipole moment. So the measurement of the SI unit of dielectric dipole is Coulomb meter, and it is defined as the product of the charges and the distance between them. It is represented by mu, and the which is equals to the product of charge and the distance between the dipoles. Thank you for watching the first session.